Hello and welcome. In this video we are going to look at how you can run your own image repository for tools like Docker. Of course you are quite capable of using the public repositories out there like Docker Hub or key.io, but it's entirely possible within your organization you will want to use a repository that is accessible only to people within your organization. Whether this is on a more permanent basis that you are creating images that are only supposed to be usable within your organization, or perhaps while you're testing out containers, testing out the containers you build from these images, before you release them out into the world, you want to keep them until they're ready for release. Whatever the reason, if you do want to run an image repository that is accessible only to people within your organization, it is surprisingly easy to do. We will need to give it a few things to make it a little bit more robust. In particular, I'm going to provide it with persistent storage so that if anything goes wrong with our container, the images are actually being held on the machine that was hosting that container. I'm going to give mine TLS encryption so that, user authentication is actually encrypted. And I'll set up some basic user authentication with HTPassword. Of course, ideally, we would probably use something a bit more robust than this, like LDAP, but I really just wanted to set up something simple here. If there's enough interest, I might do a second video where I describe how to change this over to using LDAP. The reason it is deceptively simple to do this is that there is an image that represents an image registry. So if you have a machine able to run Docker containers, you can run an image registry. We are, of course, going to need to give it a few options to make it a bit more fully functional and robust, though. We'll start off with --restart equals always, so that if this container stops for some reason, Docker will automatically restart it. There are, of course, more robust ways to do this, like run this as an actual Docker service, or use a compose file so that we can easily start something back up, but those are a little outside the purview of this video. We're going to stick with a nice simple --restart equals always. Since we want to make sure that the images stored in our repository don't get lost if this container gets deleted for some reason, what we're going to do is create a directory on our hosting machine that is going to act as where the images are actually stored, and we'll just mount that as a volume into our registry container. So in the slides here, I set up the directory /mnt/registry on my virtual machine, which we can see peeking out behind the slides in the background there. I set up /etc/docker/registry. The exact directory you use isn't terribly important. Perhaps your senior admin has a particular one they would like you to use, or your organization has one. Just make sure, of course, it's something that makes sense to other people. And the really important part is we're attaching that to the container at /var/lib/registry. That's where it is going to expect to see that image storage. So if we head over to my Docker repo machine, I've created a directory /registry. And yes, it's owned by root. Other people get read and execute permissions to it. Since we want to make sure that we are protecting our traffic from people who shouldn't be watching it, we are going to set up some basic TLS encryption. This is your typical key and sign certificate pair. I'm not going to go into detail on how to create them here. This video will already be long enough. And there's any number of other resources online that can show you how to set up a key and get a certificate authority to sign it. Of course, ideally, you are getting an actual certificate authority to sign it. You have a domain that is actually named and part of the internet, and you're paying to actually have that domain name, and you can get a certificate authority to authenticate that you really are an admin within that domain, and this machine really belongs to that domain. That is not the case for my demonstration here. I'm working within my demo domain.ca. That's not a real domain, so of course I can't get an actual certificate authority to do that. I will be using a self-signed certificate, which will have a couple of ramifications when we are connecting our clients, but those are relatively minor, and I'll talk about those once we get there. What I have done though is, again, I've set up a self-signed certificate. I've dropped a copy of that into my etc docker certs directory, which we can see there. And if we look inside that, I have self.key and self.cert. Key being the key, self.cert being the self-signed certificate. So we will need to tell our running container about those. So when we start it up, we will use environment variables to give it registry underscore HTTP underscore address, well, ADDR, to give it the address that it should be listening on and the port. I'm going to use 0.0.0.0 so that it will accept connections on any address it has. You could, of course, if you were using other options to control the IP address that your container will appear to have, you could put only that address in here so that, well, it would only accept connections coming into that address. For the actual TLS information, we'll set up the environment variables registry underscore HTTP underscore TLS underscore certificate and give it the path to that .crt file, and registry underscore HTTP underscore TLS underscore key, and provide it the path to that key file. Special note, that is going to be the path where they exist inside your container, which of course means we have to get them into that container. If you look at other tutorials online, they may actually suggest creating this key and certificate inside your container. I don't like doing that because, well, if anything happens to this container when it gets deleted, I need to go through the whole process of regenerating my key again. So what I like to do, as I've already kind of hinted at, is on my hosting machine, create the certificate there, and then we will take this, in my case, certs directory, and attach that into our running container using another -v option. So -v, wherever you put your certificate and the signed and the key, and mount that into the container at /certs. I'm going to set up very simple authentication, HT password. It's nice, it's straightforward. No, it's not the most secure. Again, you'd probably be using LDAP for this, but I just wanted a quick demonstration. This is, well, authentication is only going to be available if you've configured TLS, which is why we did that first. And just like the certificates, if you look at other tutorials, you might see things that recommend doing this from inside your container. But again, if you do that, all that authentication information goes away if that container gets deleted. So again, I like to do this from outside the container on the hosting machine, and then just provide a copy of that file to the running container. So for this, we will need the command htpassword, which means you do need to have the package http_utils. And to create a user account that will be able to log in and download and upload images, we'll run htpassword -B bn, the name of the account. When we type the password into this command, it's going to be unencrypted. This command will actually encrypt it when it puts it into, well, whatever file. And I realize as I do this, the folly of trying to use angle brackets to indicate things that you should fill into the command in the same command where I'm using those same angle brackets for redirection. So I'm quickly going to hop over to my VM and demonstrate doing this. Since we are trying to get into a file that is at least somewhat protected, this is one of those few times that I will switch over to actually being root. And I'll head into my auth directory, which we can see I had created inside etc docker. And there should be already an htpassword file in there. I'm actually going to go in and make a change. Get rid of one of the accounts that I had. And just run that again. HTTP SSWD. I could have sworn I just did this recently. Apparently it didn't save it in my history. That's fine. HTTP SSWD -BBN, the user account, norm, al user, and the password, some password. I'm not going to put a real password in here because this is obviously currently in plain text in a video, and I'm going to delete this user as soon as I'm done this recording. And I would redirect that out to, since I'm already in that auth directory where the password file is, I can just use a relative path. Of course, using my double redirection, so I add to this file instead of overwriting it. And now if I look at that file again, I've got two users. Great. And as soon as this video is done, one of those is going away. And again, I have the challenge that I have this etc docker auth htpassword file that I need to get into my running container. And we can solve that with another -v option, which I thought I had a slide about, apparently not. All I have to do is use a -v and mount that etc docker auth into my container at docker auth. Sorry, just /auth. We'll see that on the command line in a moment. We will need to set a few more environment variables when we start this container just to tell it to use this authentication. So registry_auth equals htpassword. Tell it we're using htpassword authentication. Registry auth htpassword realm, registry realm. That is, this is used for this. Like, this authentication is for this authentication. And registry auth htpassword path, the path to that htpassword file that we created as it will exist inside our container. And of course, see, I did have a slide for this. Since we created this htpassword file on the hosting machine and not in the image, I'm going to need to mount that directory into my container as well. So -v, wherever I put that auth directory, mounted to /auth. If we put all this together, we get a nice long command here. Docker run -d --name, whatever name we want to give it. I like to use registry because it's pretty self-explanatory. --restart always -p443:443. So that's pretty much all stuff we should already know. -v etc docker registry :varlib registry. So that's going to give me my permanent image storage outside of this container. -v, and I apologize for the word wrapping on the slide here, etc docker auth into the container as /auth. -v etc docker certs into the container as /certs. And those various environment variables that I mentioned, -e registry http underscore address equals 0.0.0.0:443. So whatever address this container ends up with, if you connect to its port 443, you'll be able to try to authenticate and push and pull your images. Another environment variable, registry http tls certificate /certs/self.cert, since that's what I called my certificate. -e registry underscore http underscore tls underscore key is stored at /certs/self.key. Again, the path inside the container. Another environment variable, registry auth is ht_password. Environment variable, registry auth ht_password realm is registry realm. Environment variable, registry auth ht_password path is /auth/ht_password. And finally, the name of the image we're running this from, registry. So that is a long command with plenty of options for typos in there to mess things up. I should have this in my command history. I ran this again just before the video started just to double check that it was working. Realistically, I would probably use other ways of storing this in the long term, maybe putting this command in a file and running as a script, or better yet, maybe using a Docker Compose file and running this as a Docker service. Either of those, though, is a topic outside this video. I'm going to Control-R, sudo docker run, and there it is, with all of the options that I just mentioned. And I hit enter. And there's the drawback of running this container right beforehand, is I already have a container called registry. Which I will just quietly remove. And hey, my image storage remained intact. My list of users who are allowed access remained intact. My certificate and my key remained intact. And I can just start up another container. And there it is. It's running. Now our next task, though, is to get a client machine to now connect to this registry. This video is already getting close to 20 minutes, so I'm actually going to stop here because so far everything's gone right. Well, okay, anything that didn't go right was easily recoverable from. So I'm going to stop here where we have looked at how we configure, well, how we run a registry container. And I'll have another video very shortly of how you connect one of your client machines to access this private repository that you've created. Thank you, and I'll see you in that video.